Joining us now is Dr. Kelsey Stoerzinger of Oregon State University, and also the winner of this year's Nelson Buck Robinson Science and Technology Award for Renewable Energy. Thanks so much for joining us.
It's my pleasure.
So your talk was entitled Design of Electrocatalytic Materials and Electrochemical Interfaces for Renewable Energy Conversion and Storage. Long title. Can you sum up the talk?
Happy to. So we're interested in ways that we can take renewable electricity, something that I think we're all interested in, and store that in both the bonds of chemicals, so those are of interest for fuels, and also transform the way that we do our chemical processes today. And so that relies on taking materials, things that we can drive these reactions on, and really understanding and designing them.
So what more needs to be done with this work?
Yeah, so we're really fascinated and interested by the ways that we can design catalysts. So these are the materials that really speed up reaction processes. And there's a lot of work to be done. So the things that are used industrially now for things like hydrogen production and so the corresponding oxygen production that happens in water splitting are really precious metals. So they're things that are expensive, they're not very abundant. And so something that we're working on and many other people are working on too are developing alternative materials that are earth abundant. So these are based on transition metal oxides and really making them both robust and very active for these reactions.
So how did you get interested in all of this?
My interest in material science started when I was an undergraduate, and so I was taking a kind of like a survey course in material science at Northwestern University, and there was a page in McAllister, this is a very typical textbook for an introduction to material science course, about single crystal slip in zinc, and you can kind of tell from that what inspired me and what type of science I like. So it's a very fundamental foundational thing. But I loved that you could look at the crystal structure of that material and really deduce from just math and the way atoms were bonded how it would deform. And so that was something that really inspired me to go into material science.
So was there someone at Northwestern or even outside of the university who inspired you and helped kind of guide you?
Yeah, there are lots of people along the way. So that course was really shaping for me. But then after that, I took a nanoscience course with Terry Odom at Northwestern, and then ultimately did research as an undergraduate in her research group. And that was something that really inspired me to go further down the path towards research. And I had some great internship opportunities that really solidified my desire for a PhD. And then I did my PhD at MIT with Yang-Xia Horn, another really great mentor and advisor. And those things have all really shaped the trajectory that I've gone on.
So before we let you go and circle it back more to your research, where do you see this going short-term, long-term, if you had a crystal ball?
Sure, yeah. So short-term, we're really interested in understanding the actual active interface. So historically, the way that we've thought about materials design is really based on bulk properties, things that we can probe and understand in the world around us, but in kind of ex situ conditions. And so that's been really informative. We've learned a lot from that process, but we're learning more every day about how these materials really are dynamic under the extreme conditions of electrocatalysis. And so we're working to better understand that interface and how it changes and transforms.
Well, Dr. Kelsey Stoerzinger, thank you so much, and congratulations once again on your big award.
Thanks very much.